Hi, welcome everyone. Today we are going to discuss module 11 of the CH course on session hijacking. So participants who are attending this session should be able to describe the concepts, then should be able to perform application level and network level session hijacking, then apply various session hijacking tools. So there are some tools that are there given in the guide, and you can actually have an access to those by getting an access to the labs. Uh, but there are some additional tools that I would let you know in this session. Okay. Then you can know about session hijacking countermeasures, and then perform session hijacking as part of pen testing. So the topics that we're going to discuss are the session hijacking as such, then what is the sequence number and how it can be predicted. Then we would discuss TCP/IP hijacking, also RST hijacking. Okay. Then some tools, and we would also discuss the difference between spoofing and hijacking, then the steps and types, and then countermeasures. So this is a definition that has been taken from Wikipedia. So just take a moment and go through it. So it's in computer science, session hijacking, sometimes also known as cookie hijacking, is exploitation of a valid computer session, sometimes also called a session key, to gain unauthorized access to information or services in a computer system. So a diagram is given wherein an attacker is there, a victim is there, and victim tries to log in into a server, but and server actually sends a session ID to the victim. If you remember, I have told you in previous classes that HTTP or TCP as such is stateless. I mean, there is no relation between subsequent requests until and unless there is a way we can establish that relationship. Okay, and that is done by using cookies, and cookies are set with some kind of an information, so that server can identify that this is the same person whom I'm talking to. Okay, so what attacker does is attacker tries to take this information in between, so by doing either an MITM attack, okay, or attacker can also use this information to do a denial of service by posing himself as a uh, legitimate user or the victim himself. So let's understand what a TCP session hijacking is. So when a hacker takes over a TCP session between the two machines, and this session is taken over only after the trust between the victim and the server is already established. Okay, so at the initial step itself, when let's say there is a user Alice who wants to log in into a website, okay, and she enters a password, username and password. Server sends a cookie by setting a session ID, and this diagram you can see XY52Z. And then also on the clients, from the client side, it tries to take access a page which is about the profile of the user, and then server would send a profile page. There are basically two HTTP requests here. You can see in the first line it's post, and in the third line it's actually get. So when client sends a get request, it also sends this information which the server sent it back in the previous step. Okay. To understand session hijacking, you need to understand the flow of the message packets over the internet by dissecting the TCP stack, and you need to be aware of the security issues that are involved, and you need to familiarize yourself with basic attacks that are possible due to IPv4 standards. So in the diagram below, see on the left hand side is the sending host, on the right hand side is the receiving host, and the stacks that you see here are the from taken from the OSI model. So only the physical media would actually connect these two machines, okay, and only the physical layer is connected with the physical media, but all other layers that are shown in the diagram are connected logically with each other. Okay, so data link is connected to data link, internet layer is connected to internet layer logically by way of sockets on both of these sides. So but data travels from the sending host, goes over to the network media, and then it is processed on the receiving side, and it travels up the layers. Okay, so how session hijacking is different than spoofing. So in spoofing, attacker does not actively makes use of the session of a user. So it just tries to say that I am a user and replaces some value in the packet. Okay, in spoofing, but he just pretends that he is a user to gain an access, right? But in hijacking, what happens? The victim is disconnected. Okay, it does not have any communication. It may the user may have or may not have a connection, but normally an attacker takes over the session of a user itself. Okay, so that's the difference. And the user session is taken, the victim's session is taken only after the victim has been already authenticated. Okay, so these are the steps that as part of pen testing also you can perform these. So you have to place yourself between the victim and the target, and you have to place yourself in such a way that you are sniffing on the network packets, monitor the flow, then if possible by using the tools either, or by understanding as to what kind of an algorithm is implemented, you try to predict the sequence number, or you can brute force the sequence numbers also. Okay, then you need to kill the connection to the victim's machine, take over the session, and then start injecting the packets to the target server by posing the victim himself. So these are two types of session hijacking. One is active, one is passive. So in case of passive, attacker finds an active session and takes over, and then the attacker himself is the user. Okay, and in passive, he just watches and records all the traffic and just monitors. So about TCP three-way handshake, what happens? This we have discussed a lot of time. Okay, so there are two sides: initiating peer and the receiving peer. We have already discussed SYN packet, sequence numbers, and the acknowledgement. So whenever these bits are sent from each side, they actually set this information in the packet. And once this handshake completes, then starts the exchange of data. That is of the prime interest to the attacker. Okay, and at the time when this particular handshake is happening, that information is also very, very important for him to take over. So in this example, you see Bob initiates a connection with the server. Bob sends a packet to the server with SYN bit set, means SYN flag raised. Server receives this packet, sends back a packet with SYN bit, and sets up an initial sequence number, which is basically different from the initial sequence number which was sent by the client or the Bob. Now Bob sends the acknowledgement bit acknowledging the receipt of the packet and increments the sequence number by 1. Okay. Then when the connection is established, then the exchange of data happens. So what are these sequence numbers? So they are very important, reliable for communication, as well as they are crucial for hijacking a session. They are 32-bit counters, like 32-bit numbers, and guessing them is very very difficult because for a 32-bit counter there are like 4 billion possibilities. Okay, and these numbers are used to tell the receiving machine what order the packet should go in. So packets can take different route over the network, and when they actually reach the receiver tries to assemble them as per these sequence numbers. Okay, so that they can make sense in the upper layer up to the application. So to attack, an attacker must successfully guess these sequence numbers in order to hijack a session. So as far as predicting the sequence number is concerned, after a client sends a connection a request to the server responds with SYNAC, okay, and also with an acknowledgement, which must be acknowledgement by the client. This sequence number is predictable. The attack connects to a server first, okay, with its own IP address, records this number chosen, then opens a second connection from a forged IP address. And the attacker don't see the SYNAC from the server, but can guess the correct response. If the source IP address is used for authentication, then the attacker can use one-sided communication to break into the server. Okay. So we'll see some examples. So TCP/IP hijacking. It's a technique uses which uses spoofed packets to take over a connection between a victim and a target machine. So what happens in this case is that the victim's connection hangs and the hacker is able to communicate with the host by himself. And to launch this kind of an attack, attacker has to be on the same network and the victim's machine can be on another network. So by same network, I mean the target. So here system B is the target, okay, to which the victim would connect, like system A would connect. So you can see in the diagram that the source IP, attacker actually copies the source IP of the system A, okay, and sets up a different sequence number and ACK. Just have a look at this diagram for a bit. Okay. Now there's another way wherein attacker. So this particular diagram which I just showed is an example of a passive one. Okay, wherein just monitoring is happening, and if there would have been a disconnection between system A due to some reason, say attacker would have sent some kind of a you know ACK, and system would have done a reset. Okay, so immediately the server would close the connection with the victim. So this is like a generic case of passive session hijacking, and then there's the diagram of active one. Okay, see what's happening. Like in first step, attacker actually injects some kind of a script at the server end. So whenever a victim would authenticate on the server in step 2, you can say whenever, then after that server returns the page code with that injected script of the attacker, and then victim's browser will execute the script and send a session cookie to the attacker, and the attacker would use that information to do step 5. Okay, so this is the way attacker would hijack the session of a victim by actively engaging with it. Okay, so what attacker to disconnect a client or a victim from the host to the server, attacker actually can inject a authenticated or authentic looking reset packet by spoofing the source address and also predicting the acknowledgement number. So the victim will believe that the source actually sent the reset packet and will reset the connection. Okay. And the session will actually be established with the attacker, not the victim. So some of the programs that help in performing these kind of attacks are Juggernaut, Hunt, TT by Watcher, IP Watcher, T-Site, and Paros HTTP Hijacker. Okay. So let's discuss about these tools one by one. So Juggernaut is a network sniffer. Like you know now that network packets can be sniffed. So we have already seen so many examples using Wireshark. So these tools have like additional capabilities. Okay. Juggernaut can watch all the network traffic, and it can also search for a given keyword if you have, such as a password. So objective of this program is to provide information. So it helps you in doing passive kind of session hijacking. Okay. And after some information is collected in Juggernaut, then probably attacker can use the mode in which or the type of hijacking which the attacker wants to do. Then there is a tool called Hunt. It's a program that can be used to listen, intercept, and hijack active sessions on network. It offers additional capabilities like connection management, ARP spoofing, resetting a connection, watching a connection. Both resetting and watching is provided here. It can help you in discovering the MAC address and also sniffing the TCP traffic. So similarly, there is a tool called TT by Watcher. So if you have like Sun Solaris systems with you, then you can use this tool or utility to monitor and control users on a single system. And anything the user would type in this window will be sent to the underlying process. In this way, you are sharing a login session with another user. So if a TTY session has been stolen, it can be returned to the user as though nothing has happened. Okay. Then you have a tool called IP Watcher. It's a commercial tool. It allows you to monitor connections and have active facilities for taking over a session also. Okay. And additionally, it can monitor all connections on a network, allowing an attacker to display an exact copy of a session in the real time. Okay, just to like some kind of a logging that keep happening in the background, and the user can see it. I mean, the attacker can see it. Then there is a tool called T-Site. It is for Windows, and again, you can monitor all the network connections in real time and observe the composition of any suspicious activity that takes place. T-Site has the capability to hijack any TCP sessions on the network. Okay. Due to some security reasons, Ingrate Systems, the creator of these tools, they license the software to a predetermined IP addresses only. Then there is a tool called Paros, okay, which is a HTTP session hijacking tool. So it can it's a MITM proxy and also an application vulnerability scanner. So to create these kind of packed features, you yourself can make use of combination of tools. Okay, the tool that would be like having a session on. I will try to cover it in this session itself. Will not have a separate session on a lab session on for this. Okay, we'll use burp suit. I'll give you one example. Some two utilities from burp suit and a vulnerable application. Okay. So as far as Paros is concerned, it allows you to intercept, modify, and debug HTTP and HTTPS data on the fly with the web server and client browser. Also, it supports spidering, proxy chaining, filtering, and application vulnerability scanning. So as far as vulnerability scans are concerned, if it's regard with if it is with respect to a web application, you can also have a look at a new tool which is still in beta. Okay, and additionally with Nmap you can do that, but there is a tool from OWASP. You can have a look. It's going to be released soon. Okay. So it's like more a little bit faster than Nmap. I've used it once or twice, and it's been created by OWASP, Open Web Application Security Projects. Okay, so you can combine this with the Zap proxy. Okay, I'm giving you just these tools so that you can try on your own also. To practice session hijacking, we will take some examples in further labs also, when we will take the examples on, or the labs in on web application hacking. At that time also we will discuss these tools. Okay, so you can have a look at this Zap and Net Attacker. Okay, for scanning and for doing like modifying or manipulating the request in HTTP in the case of HTTP. Okay, and additionally I'll give you a demo on perp suite right now. So some of the risks that are posed by hijacking, it's like most of the computers are vulnerable and only little can be done to protect against it unless you switch to another secure protocol. Always use secure version of all protocols. So there's one example that I showed in previous sessions, wherein clear text, posting a clear text as username and password could easily be seen with a Wireshark, like with the simple packet capture. Okay, it's very simple to launch. Most countermeasures do not work unless you use encryption. Okay, and hijacking is dangerous because somebody can uh, do a theft of identity or can commit a fraud, and there are many other things that are possible. So if you want to protect against session hijacking, always use encryption, use a secure protocol, limit the incoming connections, minimize remote access, and educate the employees in case you are doing as part of pen testing also. Then all the observations that you have noted down or documented should be used to update the training materials and also the rules with you have to set in the firewalls. Okay. So, countermeasure, use IPsec. Okay. It's a set of protocols developed by IETF to support secure exchange of packets at the layer, IP layer. Deployed widely to implement VPNs, and it supports two encryption modes, transport and tunnel. So how does it work? So in the internet, it basically establishes a secure channel by making use of encryption, by encrypting the packets. Okay. So an unprotected packet would look like this. Like there's an IP header, then there is a TCP header, and the rest of the data in clear text. But when you deploy IPsec, you actually have a security payload and then the encrypted data in the packet. Okay, in transport mode. And in tunnel mode, you actually have first IP and TCP header, all of it encrypted inside the security payload. So first you have IP and then IP address, then you have ESP and then the encrypted part. So these were the modes, and like by default, it is always there in all secure organizations. In most of the applications, it implemented. Okay, but when you do your scans and you find out, then you will come to know more. Okay. So what we have discussed, so in case of session hijacking, an attacker relies on the legitimate user to connect and authenticate, and then will take over the session. Okay. In a spoofing attack, you might have seen this example, like in sometimes movies it is shown, right? That if there is a telephone that is coming and someone else is actually listening onto the same line. Okay, so a classic example of doing an MITM and somebody actually hijacking a session. And even if someone is disconnected, then the other person is actually holding on to that particular line. In a spoofing attack, the difference we have discussed, spoofing and session hijacking. So in a spoofing attack, attacker pretends to be another user or machine to gain the access. And in case of session hijacking, attacker takes over the session, right? Successful session hijacking is extremely difficult and is only possible when a number of factors are under attacker's control. So session hijacking can be active and passive in nature, depending on the degree of involvement of the attacker. A variety of tools exist to aid the attacker in perpetrating a session hijack. So we have discussed so many tools, and it could be dangerous, and therefore you need to apply, you need to prevent, and you need to apply all the measures that we have discussed. Okay. So let's take a small, let's discuss one example also. I'll tell you about evil jinx later. So we need a vulnerable app. Okay. So yeah, I did not tell you about this application that you can try yourself. We can take many examples later from this app. So there is an application called it. This is a book. You can have a look. Additionally, you can go and have a look. Then yeah, have a look at this. Okay, OWASP Juice Shop. It's a web app. Okay, and it can help you in understanding web application vulnerabilities, and there are a lot of things you can gamify, and actually you can play with this application, and there are various challenges also. Okay, it's a flagship project, right, to understand web applications. So I'm going to use this. So as of now, I've just started it on the local on this machine. It will take some time to be available. Meanwhile, let me start the proxy that we are going to use, burp suit. The free version is there with the Kali distribution that you have. Always remember that first you need to start burp suit, and then you should open the browser and enable the proxy in it. Okay. So we would be making use of two tabs in it. One is called proxy tab, and another one is repeater. So general idea is that we would try to capture the requests that are sent on the application with this. Then we would modify something in that request and resend it with the help of repeater. So this is a very vast tool. So just to cover the concept on session hijacking, I'm going to use only the proxy tool, and you should know that how to put intercept on, how to intercept those requests. Then you should know how to look at the HTTP history. Okay. And then once you know that this particular request was used to send the username and ID, then you should be able to, or some other post request which was sent to the web server, then you should be able to take that request to the repeater, and from the repeater you modify and then resend that request to pose yourself as an attacker. Okay. So let's see if the application, yeah. So let me just zoom in. So it's the application is listening on port 3000. Okay. Okay. So I can access the application. So I need to log in actually, and whenever I use burp suite, I make use of Firefox. Okay, because I have configured proxy in that browser. So please make use of. It's very easy to configure proxy in Firefox. You need to install a plugin called, or add-on, I would say. Okay, and with a single click, you can turn on and turn off the options. Like say I've defined the options for burp, and let me show you the options. Okay, so you can actually select the proxy type, the IP address, or you can specify the DNS name, and then you can specify the port on which the proxy is running. Okay, then on the same port, burp should be running. Okay, so once you save it, then you can actually enable it by just doing a click. So let's check if the proxy is on or not. So when I give the URL to localhost 3000, the request automatically is opened. If the intercept is on, the request is actually captured by or intercepted by burp suite, and I can see that request, right? In the raw format, I can see the parameters, I can see headers. Okay, and to let the application function, if the intercept is on, you need to click on forward. So once you forward, keep forwarding until no request is left in the window. Okay, so I'm just clicking on forward. Yeah, so you can see now nothing is there in the window, and then I can either let me just put the intercept off and show you the application. So in your free time, please have a look at this application, go through it, understand the features, and I won't be covering in detail as to what are the features. Okay, it's a e-commerce example e-commerce web application, and on the right hand side there is a link to login. So you need to register yourself by clicking the link below the form, wherein not already a customer. You can give any email and you can give a password, repeat the password, fill up this form and get registered. So as soon as you get registered, you can log in the account. Okay. So I have one user called test user1 at email.com, and I have the password, and now I can log in. But just before logging in, I'll put the intercept of burp suite on. Okay. Now it's on. So I go back to the application and click on login. So you can see that nothing has happened. Okay, why? Because this particular uh, request has been captured by the verb suit. So on the screen, you can see that this particular application is actually sending my email and password in clear text. Okay, so this is one way of getting to know the information. Then you click on forward. Keep clicking forward until there is no request left in verb suit. Okay, in the intercept tab. So there is no request left. Now let's go and have a look at the application. Okay, maybe I gave a wrong password. Wait. Okay, I think on every what do you call this? Every restart, I have to uh, register it as a user. Okay, let me just register. Anyway, that part of so I will ensure that I have put the intercept off. Let me register first. So test user one at email.com, and I'll give the password as 12345. Okay. Some random answer, question and answer, and register. So it says that registration completed successfully, and now you can log in. So these steps you have to do from the tester's point of view. Okay, so you log in, and then I'd say test user one at email.com, and I'll give the password and log in. Okay, so once I log in, I'll have access to a page, which is the search page, and it lists products that I can buy. Okay, say I want to purchase Apple Pumas, and I can click on add to basket. Okay, so but before doing these post operations, and when I do add to basket, it will be added to my basket. Okay, so before doing this step, I'll just put the intercept on in Burpsuite, come back to the application, and in case in between some additional posts or some requests are happening, they also will be captured. So for that, you need to just carefully click on forward until there is no request left in the intercept tab under proxy tab of Burpsuite. So now come back to the application and I say add to basket. So once I click on that add to basket, it will be captured. And I'll again click on forward. So this is the request that we need to, it's a post request uh, that we need to, focus on for modifying some kind of a detail uh, or modify the this request headers or the data. So just keep a note of it. So even if you don't, if you're not paying attention while you are forwarding the request, then also it is okay. You can actually access this request in the HTTP history. So we keep clicking on forward until there is no request left. Okay. Now I go to HTTP history and look for that post request. Okay. So there's a post request on API users. There is a post request on API security answers. There is a user login post request. So if you'll, I'll just scroll it up. So when I go to user login post request, I can see the email and password in clear text. Then I can see that server actually responds with some kind of a token and a BID and a user email. Okay, and a response, I can see that. Then I go to a post request wherein I tried to add the items. Okay. So you can see that product ID is being sent in the request. The basket ID, the cart ID is being sent as 6, and the quantity is also being sent as 1. So if imagine that when you are actually purchasing something from an e-commerce website, and there is an intermediary in between who is actually intercepting these requests in between, then someone can modify those requests and can cause some kind of a fraud. And also can, like, let's say you are buying some 100 items, like your 98 items or something, and additionally an item is included, so that uh, you know an additional purchase is made on your name. That can happen. So this is one of the risks. Then also you can actually modify the basket ID itself, and the product might get added in someone else's basket. Okay, that can also happen. So I'll tell you how to do that. When we highlight that particular post request, you have to right click it, and there's an option in the context menu which says send to repeater. So as soon as you click on send to repeater, you can go to repeater tab and can see the request. So you can see that authorization bearer, details are already set. This you can make use of this request. Okay, and this particular cookie which has the information on product ID. So let me, just increase the quantity. I'll just increase the quantity to 4 or maybe 2. Okay. I'll modify this here and I'll click on send. So, but it says that there is some problem with it. Okay. There's some kind of an error that has happened. So maybe, the application allows only, let me say, what is the validation error? It says basket ID must be unique. Okay. Which is actually 6 as of now. It's given as 6. Okay, let's do something with the product ID. Okay. Let me add product ID as 1. And when I actually change the product ID and the quantity, it has actually sent me a success message in the response. The application has sent me a success message in the response. Okay. Now let's have a look at the cart. So if I go and click on it, it will probably show it to me. So let me first go and switch the intercept off. Okay. And let's observe the cart. So you can see from the user interface, we actually added the apple pomace. But now in the cart, we have apple juice also. Similarly, during checkout, this particular attack can happen, right? Someone can, steal your credit card information or CVV or anything. Like if someone is there listening on the wire, okay, or sniffing your packets, or doing session hijack. So where with session hijacking, what kind of attacks you can perform by doing session hijacking? You can perform a DOS also, and you can perform man in the middle attack, right? So there are others, browser man in the browser also, that you can have a look at in the guide. There are some attack types that are discussed. So those you can do session hijacking on network. Yeah, this is the example that I gave you of hijacking a particular session with the help of a proxy. Like the example which we discussed in the slides was Paros. And if you want to perform the steps in Paros, then you can please have an access to the lab, and then you can try it there. Okay. So we have like another 10-15 minutes. So I'll just let you know a little bit on. So you can actually change the ARP cache, you can change the DNS cache, and then you can also make use of a framework to host a website on the internet, posing as a different website itself. Okay. Then once you gain an access to the network of a user, okay, or the target, and you can host your own DNS, a domain name server, or you can actually poison the cache of existing DNS server which is being used in the network, the victim's network. Okay, so all of that can be done to hijack the sessions of users. Okay, so just read about a tool called Evil Jinx. Okay, why it is of prime interest? You can actually fish for login credentials with session cookies. You can also bypass two-factor based authentication protection. So if I remember, this particular tool, Evil Jinx, was used to hijack details of users who use Microsoft Office 365. Okay, how that was done, please read a case study on internet and find out how it was done. So but it's quite a big framework. Okay, and there are some guides also available, video guides you can have a look at, and some of the users who've contributed. Then there are steps of actually installing it. Okay, you can also make use of a pre-compiled binary package for your architecture, and if you want to build it from source, then you can actually use these commands to do that on Linux. And if you are using Docker, then also you can build it for Docker, build the Docker image, and you can run it with this command. Okay, and there's one like, let's say I just wanted to give you an example on creating a fake site. Okay, so just let's say, okay, wait, I'll just switch this off. So there is something called Cyrillic characters. Okay, I'll just, see, you can I'm just making use of this input tools by Google to let you know the difference. Okay, so let's say there is a, in English, okay, I write the word hacker. Okay, and on the next line, if I maybe, wait, in slow work, I'll write the word. Okay, I don't think here that particular key can be used. Let's see what it types. Okay, and let's make use of ASCII to Unicode. Some tool that you can make use of. Okay, wait. I think when I was doing it earlier, I think it had that. So these two strings that you see on the notepad, they are very, very similar, but they're actually different. Okay, let me just, yeah, see this. The A in the first, the A in the first line is actually a different character in Unicode. Okay, and A in the second line is actually the A that we normally see with our eyes. So what people can do with this value, they can register the domains with the domain providers, and when they actually, when users try to browse this kind of a website, they won't come to know, and they can actually mirror the whole website, full website, and attacker victim will not come to know that somehow I am being routed to a fake website. Okay, that's one of the ways a user can be routed while the user has already authenticated. Okay, and the user can keep using the fake website, and the attacker can use the real website by hijacking the session of a user. So try to read about the case studies on Evil Jinx 2 of MS65, Microsoft Office 65, and wherein techniques such as simple as this can be used to dupe users into going to the fake websites. Then you can have more control on the victim or the target network. So we have come to the end of the session for today.